Honeycomb structures are natural or man-made structures that have the geometry of a honeycomb to allow the minimization of the amount of used material to reach minimal weight and minimal material cost. The geometry of honeycomb structures can vary widely, but the common feature of all such structures is an array of hollow cells formed between thin vertical walls. The cells are often columnar and hexagonal in shape. A honeycomb-shaped structure provides a material with minimal density and relative high out-of-plane compression properties and out-of-plane shear properties. Man-made honeycomb structural materials are commonly made by layering a honeycomb material between two thin layers that provide strength and tension. This forms a plate-like assembly. Honeycomb materials are widely used where flat or slightly curved surfaces are needed and their high specific strength is valuable. They are widely used in the aerospace industry for this reason, and honeycomb materials in aluminum, fiberglass and advanced composite materials have been featured in aircraft and rockets since the 1950s. They can also be found in many other fields, from packaging materials in the form of paper-based honeycomb cardboard, to sporting goods like skis and snowboards. Natural honeycomb structures include beehives, honeycomb weathering in rocks, tripe, and bone. Man-made honeycomb structures include sandwich-structured composites with honeycomb cores. Man-made honeycomb structures are manufactured by using a variety of different materials, depending on the intended application and required characteristics, from paper or thermoplastics, used for low strength and stiffness for low-load applications, to high strength and stiffness for high-performance applications, from aluminum or fiber-reinforced plastics. The strength of laminated or sandwich panels depends on the size of the panel, facing material used and the number or density of the honeycomb cells within it. Honeycomb composites are used widely in many industries, from aerospace industries, automotive and furniture to packaging and logistics. The material takes its name from its visual resemblance to a bee's honeycomb, a hexagonal sheet structure. The hexagonal comb of the honeybee has been admired and wondered about from ancient times. The first man-made honeycomb is said to have been manufactured by Daedalus from gold by lost wax casting more than 3,000 years ago. Marcus Varro reports that the Greek geometricians Euclid and Zenodorus found that the hexagon shape makes most efficient use of space and building materials. The interior ribbing and hidden chambers in the dome of the Pantheon in Rome is an early example of a honeycomb structure. Galileo Galilei discusses in 1638 the resistance of hollow solids, art, and nature even more, makes use of these in thousands of operations in which robustness is increased without adding weight, as is seen in the bones of birds and in many stocks that are light and very resistant to bending and breaking. Robert Hooke discovers in 1665 that the natural cellular structure of cork is similar to the hexagonal honeybee comb. And Charles Darwin states in 1859 that the comb of the hive bee, as far as we can see, is absolutely perfect in economizing labor and wax. The first paper honeycomb structures might have been made by the Chinese 2,000 years ago for ornaments, but no reference for this has been found. Paper honeycombs and the expansion production process has been invented in Halle/Saal in Germany by Hans Heilbronn in 1901 for decorative applications. First honeycomb structures from corrugated metal sheets had been proposed for beekeeping in 1890. For the same purpose, as foundation sheets to harvest more honey, a honeycomb molding process using a paper paste glue mixture had been patented in 1878. The three basic techniques for honeycomb production that are still used today, expansion, corrugation and molding, were already developed by 1901 for non-sandwich applications. The three traditional honeycomb production techniques, expansion, corrugation, and molding, were all developed by 1901 for non-sandwich applications. For decorative applications, the expanded honeycomb production reached a remarkable degree of automation in the first decade of the 20th century. Today, honeycomb cores are manufactured via the expansion process and the corrugation process from composite materials such as glass-reinforced plastic, also known as fiberglass, carbon fiber-reinforced plastic, Non-exaramide paper reinforced plastic, or from a metal, usually aluminum. Honeycombs from metals, like aluminum, are today produced by the expansion process. Continuous processes of folding honeycombs from a single aluminum sheet after cutting slits had been developed already around 1920. Continuous in-line production of metal honeycomb can be done from metal rolls by cutting and bending. Recently a new, unique process to produce thermoplastic honeycombs has been implemented, allowing a continuous production of a honeycomb core as well as in-line production of honeycombs with direct lamination of skins into cost-efficient sandwich panel. Today, a wide variety of materials can be formed into a honeycomb composite. For example, paperboard honeycomb is used in paper pallets and package cushioning, blocking and bracing.